Hello viewers, welcome back to another section of the multivariable calculus tutorial. We saw many examples in our previous tutorial, so if it's your first time you are meeting us for this tutorial, kindly subscribe so that you get notified when I post new tutorials. Watch the video to the end so you understand every part of the video. In this video, our central matter is line integrals. We're going to solve for line integrals over a line segment. Please watch the video to the end and don't miss any part of it. So in finding line integrals, you ask yourself, what do you need? So it's simply integral c, then I have my f, that is a function h of t, a function g of t, then I have my ds. But I realize that the s is simply the square root of what I have here, h prime of t squared plus g prime of t all squared. So depending on the number of variables given, you can get 3, but in our case they give us 2. So if they give you a function of x and y, the next thing you're going to do is you have to parameterize this into t so that you can go ahead and solve the line integral. How do you do the parameterization? Whenever you are integrating a line over a line segment, giving a point to another point. So I have from point 36 to point 1, -1. You simply have to solve for your parametric equations. That is, you find your r of t, and that is generally given as 1 minus t multiplying our first point 36 plus t multiplying 1 -1. So the rule is always 1 minus t will multiply the first point plus t will multiply the second point. That is from 2. Yes. We expand this and I'm going to get 3 minus 3t. Then I'm going to get 6 minus 6t plus t negative t on this side. And I know you can simply do this. So this plus this, I'm going to get what? 3 minus 2t. This plus this, I'm going to get 6 minus 7t. Right. So from here I can say my x is equal to 3 minus 2t, y is equal to 6 minus 7t. Once I have my parameterization done, I move straight to finding my ds, which is equal to the square root of my x prime of t all squared plus my y prime of t all squared. So I can simply say that this is equal to, when I find this, I'll get -2 squared plus here -7 squared, and that is giving me square root of 53. Now I have my ds. I go back to my function and I'll make my necessary substitution. But take note, whenever you use the parameterization of a line, your limit for t is going to be greater than 0 but less than or equal to 1. That is what the rule is saying. So you're going to have your integral 0 to 1, and in line integrals it's simple. It's just a single integral, it's not double. Take note. So 0 to 1, then you come back to 3 open brackets, 3 minus 2t all squared, right? Making the substitution. Minus 2, our y is simply what? 6 minus 7t. Then our ds comes as 53, square root of 53 dt, as you have here. Then the next thing is to simplify this expression, right? So we're going to simplify this expression. And how do you go about that? So if you have this, I'm going to have my 3 out. So let me simplify here. Integral 0 to 1. This becomes 3 multiplying 9 minus 12 t plus 4t squared. Then this place is minus 12 plus 14t, everything multiplying square root of 53. So this is further simplified so that you're going to get 27 minus 36t plus 12t squared minus 12t plus 14t. So minus 12, everything multiplying square root of 53, 0, 1. Now I still simplify. I have my 36t, I have my 14t, I have 27, I have 12. That's going to give me what? 15. Then I have 36 and 14 minus 22t. Then that is going to give me plus this 12t squared, like this. Then square root of 53 attached. So this just integrating each, right? Yep. So upon careful simplification, realize that you're going to get our square root of 53 out. Then here I'll get 15t minus 11t squared plus 4t cubed. Then I bring my 0, 1 nicely. So once I do this, when I put 0, everything will be 0, so I'm interested in the 1. So you just take a calculator, you punch 15 multiplying 1, then minus 11, then plus 4. That is simply giving us what? 8. So that is simply giving us 8 root 53, multiplying that. So this is the end of this video. See you in the next tutorial. Don't forget to like, share and subscribe.